Welcome to the video presentation on Doubly linked list and circular linked list. This is Sweetlin Hemalata, Assistant Professor, School of Computing Science and Engineering, VIT Chennai. The prerequisite of this presentation is that one should have the knowledge of singly linked list. Having known the concept of singly linked list, it is very easy to follow the idea of doubly linked list, as it is just an extension of the structure of singly linked list, which has a node with two fields, data and next field, whereas a node in doubly linked list has three fields, namely the data field as usual. Besides the next pointer, we do have an additional pointer named prev, which points to the previous node. As shown here, prev contains the address of the previous node and next contains the address of the next node. So, doubly linked list is a data structure which contains set of elements in which each element has three fields. One thing is data field and two pointer fields, prev and next. This is a sample doubly linked list L, which contains four elements 10, 27, 65, 35, and head pointer always points to the beginning of the list so that the list can be traversed. So you can see all the nodes has two pointers. Here the next field points to the next node 27. Similarly, the previous field of 27 points to the node containing data 10. So all the nodes are having the next and prev, where except the first node and the last node. In the first node there is no previous node, so it is prev pointer of the first node is set to null, and the last node has no further list to follow, so the next value of last node is set null. How to define the structure node? So here in C programming language we have a data type known as structure that is used to define a variable that can handle more than one type of data. See, here we have a structure node in which we have a data of type integer. It can also be string, character, float, etc. And we have two pointers, prev and next, of type node itself. Here in this case, if you consider a node, this is the data of type integer, and we have two pointers which are pointing to another node type. So a structure node is the type of the node that is pointed to by prev and next. Coming to the operations in a doubly linked list, we can do search, which returns the address of the node at which we find a match with the search key K, using a simple linear search, that is starting from the first node to the last node. If the search key is not present in the list, it returns a null pointer. So searching operation is done in more similar way as that of singly linked list. This is the pseudocode for the same. We have a search module, okay, for the list L and the search key K. Initially we assign the address of the first node, which is in head, to a temporary pointer variable that is temp, because we are going to traverse the list in search of the key K. In that case, if we tend to change the address of the first node, that is the header pointed to by header, then we will lose the real address of the starting node. So to avoid that, we assign the address of the first node to some temporary pointer variable. It is temp here, and we traverse the list till we reach the end of the list or till we find a match. If we exit the loop upon satisfying this condition, temp not equals null, means that temp is equals null, and we have searched the entire list and the element is not found. In that case, temp is null. And other condition is temp of data equals K, in which case we found a match. In either case, we return the temp will be equal to the address of the node containing the key K if K is there, otherwise it will be equal to null if K is not present in the list. Coming to the operation insertion into a doubly linked list, there are 4 possibilities for insertion. That is, insertion can happen at the beginning, insert at the front, or at the end of the doubly linked list, or anywhere in between front and end, that is insert at the middle. Let's see one by one. Insertion at the front. Let us consider the case like the doubly linked list is empty, in which case the head is null, it points to null. So there is no element in the list is empty. And this is the new node which is to be inserted at the beginning of the list. Okay, that contains the data 21. And how the connection has to be established. Now head is pointing to null, and now it should be made to point to new node. So now head is pointing to new node. Okay. Then the new node is pointing to head. Suppose if you are maintaining head as a separate node, this kind of modification is necessary. Suppose this new node itself is going to be the head, just we have to assign head as the new node. Now consider the case the list is not empty. We have the list with some elements as shown here. Now head is pointing to the first node which contains the data 10. Now what happens if we insert this new node 21 at the beginning of the list? Now after insertion, head should be the node with the value 21, and the next of this one, next of node 21 should be point to the previous head, and the head should be modified to the new node. So you have to make changes in the next part of the new node, and the previous part of the previous part need not be changed because it is going to be the first node. Let's see how it is happening. Next part, null is clear and it is connected to the previous head. Head contains the address of the node 10. It is now available in head. So the next part of the node 21 is now pointing to the node containing the value 10. And the previous node of this node 10, which was null earlier, now you have a previous node which is 21, because 21 is the first node. So now the previous pointer of the node 10 pointing to the new node, and I should make this new node as the head. There is no more head now. Head is now 21. Now the list is, this is the head node, so it starts from here 21, 10, 27, 65, 35. Once you have reached the end of the list, using the previous pointer, you can trace the list in the backward direction too. 35, 65, 27, 10 and 21. That is the advantage of using doubly linked list. This data structure allows the list to be traversed in both forward and backward direction by using the next pointer and previous pointer respectively. This is the pseudocode of insertion operation at the beginning. Insert begin. So if the list is empty, means that head is equals null, we just assign head is equal to new node, the newly created node. If the list is not empty, then we have to set the address of the new node next pointer, that is new node of next is equal to the previous head, which contains the address of the previous first node. Now head of previous, so far head has not been updated, it is still the recent first node, so head of pre should be made to point to new node. Once these changes are done, then you can make a new node as the head node by this assignment head is equal to new node. Coming to the operation of insertion at the end, inserting node as the last node. Consider the case as list is empty, head is null here. Now we have a new node with the data 21. Now for inserting this as the last element, it's done similar as that of the previous case, but for list that is not empty, we have some elements in the list and the first node is having the value 10 and the address of this node is available in head. Now we have the new node created with the data value 21, and this has to be inserted as the last element in the list. For doing so, what are the changes we have to make? First, we should know the last address of the last element. Let us consider the address is now available at the pointer variable temp. This can be obtained by traversing the list from the first node and reach a node for which the last next part of the node is null, which is used to indicate the last node in the list. So we have obtained the address of the last node by traversing the list and settling in the node having the next pointer value as null. Let us consider the values available in temp. Now what change we have to make? Now if you want to insert this node, this cannot be null. So the next of the last node is adjusted to point to 21. Next adjustment is, now this node has a previous node in the list which is 35. So this previous pointer of the new node is made to point to 10. Now the list has 10, 27, 65, 35. After 35 we have 21, and we can also traverse in the reverse direction by using this pointer pre. So we have inserted the node 21 at the end of the list. The pseudocode of the insertion operation at the end goes like this. Initially we are assigning the address of the first node which is there in head to temp, and we are traversing the list till we find a node for which temp of next is equal to null. So temp will be holding the address of the last node at the end of the while loop. Now with this information we just make temp of next, which was null initially. Now it is made to point to the new node, and we have a previous node for new node. New node of previous is adjusted to point to temp. Now insertion at the middle. Insert 25 after 65. We have 65 here, and this is the new node to be inserted. Now we can simply search the list from the beginning, like 10, 27. Then once you have reached the search key 65, we can stop. Unlike in singly linked list, we need not have a separate module for finding the previous node of the node 65. Now let us consider this is temp, which is the address written by the search module by searching the key 65 in the list. Then what is the pointer adjustment we have to make? The next node, next pointer of the new node, which was null initially, is now modified to point to 35. How do we get the address of this node? With the help of temp. Temp of next contains the address of this node, which should be assigned to the next pointer of new node. Once you have modified this one, now the 65 is no longer the previous node of 35. Now the previous node of 35 is 21. So modify the previous pointer of 35 to point to new node. That is second operation. Third one is the pre-pointer of the new node should be pointed to the node 65 whose address is available in temp. Now the last thing is the next pointer of the 65, which was pointing to 35 previously, should be made to point to new node. By doing so, the pointer connection which was there previously got cancelled. Now the list is something like this: 10, 27, 65. After 65 it comes to 21, then next is 35. From 35 it's 21, 65, 27, 10, like that. Now we have inserted a new node in the list after 65. You can also try inserting any node before any data value in the list. The pseudocode for insert middle goes like this. First we have to get the address of the node K, after which this new node X is to be inserted. So we use the module search by giving key value to be searched in the variable K. So temp will contain the address of the node that contains the search key K. If temp is not null, means that the key is present. So what were the connection changes we made there, the same thing is represented in the form of pseudocode. New node of next is made to point to temp of next. Temp of next of previous is made to point to new node, and new node of previous to temp, and temp of next node to new node. So what were the connections modified there with the numbering 1, 2, 3, 4 were presented accordingly in pseudocode here. Suppose if temp is equals null, means that the search is not successful, the key is not present, so we are printing a error message like invalid position. Having seen the operation of insertion, let us see about deletion. So delete also has three possibilities. We can delete the element at the front, the first element in the list, or we can delete the last element in the list, or we can delete any element in between front and the end. Let us see one by one. Delete front. Now consider a list with 4 elements 10, 27, 65, 35, and the head is now pointing to the first node that contains the data 10. Now this is the first node. Delete front module will delete the node containing 10, and 27 should be made as the first node. So this can be done by changing the pointer of head. Head was previously pointing to node 10, now it is modified to point to this node. How do we get the address of this node? This address is present in the next part of the head, which was head before. So head has to be modified as head of next. If you do that modification, automatically this link will get cancelled, and we have to make the previous pointer of the current head to null, because there is no previous node, as this is the first node in the list. So this accomplishes the task of delete front, and the pseudocode for the same is presented here. If head is not null, means that the list is not empty. We have to just update the head as head of next. Now head will be the new, this node 27, then the current head of previous should be made to null. If the list is equals null, means the list is empty, so deletion cannot be performed. Then delete end. Delete the last element in this list, which is 65. To delete the last element, we have to traverse till the last but one element and make this next point of node 65 to null. By doing so, we are actually cutting the link. But in the case of singly linked list, we will, if this is the node to be deleted, we will be traversing the list and ending up with last but one. But in the case of doubly linked list, since we have the pointer to the previous node, we can always go to the last node in the list. Then using the previous pointer, we can go to the previous node. We don't need a separate procedure to find the last but one node or the previous node of any node. There is one way. I have stopped with temp, that is last but one node, and made the next pointer of this temp node to be null, so no further node follows it. By this the connection get cancelled. The other way is you traverse the list till you reach the last node, in which case temp will be this node, and you can always go to the previous node, in which case the previous node is obtained by temp of previous, then make that next pointer as null. So the pseudocode is shown below. Delete middle, that is middle element is 65. So here I have mentioned you need not go to the previous node of delete for deletion. You can search for the node containing the data value 65. So here that node's address is available in the pointer variable del node. Then if I want to delete this node, I have to make appropriate pointer correction in the previous node, that is 27, and the node containing the value 35. I can get to these nodes by just using the pre-pointer and next pointer respectively. So I don't need a separate module like find previous as it happens in the case of singly linked list. So now I search the entire list and end up with the node that contains the value 65, which is to be deleted. Now del node contains the address. To get the previous node's address, just it is del node of pre will get me the address of the previous node. Now consider that is stored in pre node. And to get the address of the next node, actually this is next node, so we just use the next pointer to get the address of the next node. Once I get all these values, I make the pointer adjustment like this. The next pointer of previous node should be pointing to 35. Previously it was pointing to 65, so this next connector will get cancelled. Then this node's previous node is 27, so the previous pointer of 35 is made to point to 27, which is whose address is available in pre node. By doing this connection, the pre connection from 35 to 65 is getting cancelled. By this we have the elements 10, next 27, next 35, and the reverse order is 35, 27 and 10, and we have deleted the node containing the value 65. And this is the pseudocode for the same. First we call the method search by passing the element to be deleted. Now the address of the node to be deleted is available in del node. If it is not null, means that we have a node with that value we are expecting, and then we get the previous node by del node of pre and the next node by del node of next, and the previous node of next is made to point to next node, and the next node of previous is point to the pre node. So if the list is empty, then deletion is not possible. Or what are the advantages of doubly linked list? The back button in the browser and undo function in MS Word, which are the best examples for stack data structure, and stack can be implemented with doubly linked list. Anything represented that can be represented as a list can be implemented by means of doubly linked list. The application that needs most recently used elements can be arranged as a doubly linked list. And memory management in operating system like malloc function and free function in C and new operator and delete operator in C++. These functions and operators are used for allocating memory space and deallocating memory space dynamically. So for doing so, you can have the heap as a doubly linked list. Having so facilitates traversing the memory space in both forward and backward direction. Then coming to the circular linked list, we have a slight variation in the structure again. So here you could see this linked list singular linked list with a slight variation that the last element is again, the next of last element is again pointing to the first element, so that the linear arrangement becomes a circular arrangement. So a circular linked list is a data structure in which the last element points to the first element in the list, forming a circle. So there is no null at the end for the last node. There is no last node because we have a circle rather than a linear list. A circular list can be singly circular linked list or doubly circular linked list. So this is a structure of singly linked list, and we have the next pointer of the last node pointing to head, and this is a structure of doubly linked list where we have both next and previous pointers, and here again the next pointer of the last node is pointing to the head, and to form a circle the previous pointer of the first node is again pointing to the last node. I mean, not the last node, that is 35. Here now it is a circle. So here we are going to see the insertion and deletion operation at the end. See, this is a singly linked list, singly circular linked list, and we have a new node which is supposed to be inserted at the end. So we should have a list like 31, 10, 27, then 21, again 21 should be pointing to 31, 10, like that. So we have to do some pointer adjustment in the current last node. Let us consider the pointer variable temp contains the address of the current last node, which can be obtained by traversing the list from head, that is the first node, and reaching the node for which the next pointer of the node is again pointing to the head node. So having settled in the current last node, we have to make the next pointer of the temp to point to 21, that is new node. Now we have the list 31, 10, 27, next is 21, but here we have a null. This should be updated to point to head. So that should be updated and it is now pointing to head. So the previous pointer, because of this adjustment, this connection gets cancelled. So then delete end. We have a list singly circular linked list containing 4 elements, 31, 10, 27 and 21, and this is the element to be deleted. After doing so, I should make the last but 1 element's next pointer to point to the head. That is the possible pointer change we can make to delete the last element. Let us consider again temp contains the address of the last but 1 element. We have to traverse the list and identify the address of the next of the node pointing to head, that is the last node, and you have to stop prior to that. So this is the temp. The address of the last but 1 node is available in temp. Now I am making the next pointer to point to the head. So this cancels this link. When this link is getting cancelled, automatically this link is also getting cancelled. So we have a list 31, 10, 27, again 31. So the last element is deleted. You can also think of other operations like insert in front or else insert in the middle, anywhere else between front and end. Similarly, deletion can happen at the first node, or deletion can be anywhere else in the middle, which will be more similar as that of ordinary singly linked list. And again, the same idea of singly circular linked list can be extended for doubly circular linked list. Coming to the advantages of circular linked list. Since the structure has the next pointer pointing to the head node, and from the last node we can traverse to the first node. So this structure facilitates the arrangement of objects in a circular fashion. The whole list can be traversed considering any node as the starting node and traversing the elements in the list and stopping while we visit the node that was visited initially. That is the advantage of using circular linked list. Then this kind of structure can be used to implement a circular queue. Operating system also puts time sharing application in which each application waiting for getting CPU time will be given a time slot or placed in a circular list. And this kind of list is also used for implementing more advanced data structures like Fibonacci heap. With this, we have come to the end of this presentation. Thank you.